Hello, welcome to Math 1324. This is Chapter 10, Section 1, Example 6. In this example, we want to give the domain of the function defined below. We have f of x equals x minus 6 all to the 1/2 power. Okay, so first of all, we can tell that it's a function, first because it's defined as a function in the question, but also because we have f of x here. Now, what we mean by this is x minus 6 to the 1/2 power. This is not a polynomial. Polynomials use integer, in fact, whole number exponents. And so, since that's a fractional exponent, this is not a polynomial. Okay, so this is one thing that we're going to have to understand here. Anytime you have a base to a fraction as an exponent, we're not actually dealing with just regular exponents. The numerator is a regular exponent, but the denominator actually tells us what we call a radical. So now a radical is this symbol. Okay, so it's, in this case, the root symbol. Now, that denominator tells me the index of the radical. And the base here, the a, the base, is actually going to be underneath the radical. And at that point, we wouldn't call it the base anymore. We would call it the radicand, because whatever's underneath the radical is called the radicand. And that means that all of this now becomes the base all to the mth power. In other words, this is just some number to the mth power. That would then be just a regular exponent. So base to the fractional exponent means the nth root of a, all to the mth power. Now if we look at that and apply it to f of x equals x minus 6 to the 1/2 power, what we actually have here is f of x equals, now the denominator here is 2. And so that means that we're going to have the root symbol with a 2 right there, kind of, but we don't ever write it. It's like putting a 1 in front of a variable. So technically this is the square root of whatever the base is, which in this case is the x minus 6, and then all of that will be to the first power, because that is the numerator there. But we never really write anything to the first power, so technically x minus 6 to the 1/2 power just means square root of x minus 6. Good. Now that we've seen what this actually means, we can talk about the domain. There are going to be two things that limit our domains, and you're actually seeing one of them right here. So the first thing that's going to limit our domains will be what I call even radicals, or let me be a little bit more clear than that, even indexed radicals. And what that means is, as long as you have an understood 2 there, or 4 there, 6, 8, so on and so forth. Now the 4, 6, and 8 wouldn't be understood. It would actually be written. But if it's not even written, it's an understood 2. As long as the index is an even number, an even integer, then you are going to limit your domain. And here's the reason why. So again, whatever is underneath the radical is called the radicand. When we take the square root of a number, if we want a real number out of that, then the only way to get that is to have the square root of the lowest number that we can have underneath the radical would be 0, because square root of 0 is 0. But anything smaller than 0, you're going to get imaginary numbers. And so as a result, we don't consider those to be part of the domain, because there's something called the agreement on the domain. Let me go ahead and write that down here. And it basically says, unless stated otherwise, the domain of a function is the set of all values instead of all independent values that produce a real y value, a real dependent value. Okay, so that's what we have here. So the agreement on the domain says that unless stated otherwise, the domain of a function is the set of all independent values that produce a real dependent value. Okay. So as a result, what that means for us is to find the domain for even indexed radicals, what we're going to do is take the radicand and set it greater than or equal to 0 and then solve that inequality. And once you have that inequality, put it into interval notation. So for even indexed radicals, here's what you need. Whatever's underneath the radical must be greater than or equal to 0. Let's see how that works here. So we have f of x equals x minus 6. That means we're going to take the radicand, the x minus 6, and set it greater than or equal to 0. And then we just solve this. Well, how do you do that? You add the 6 to the right-hand side, making this x and 6 over there. Do we flip the arrow? Ask yourself that. No, because we're just adding or subtracting here. So greater than or equal to 6 here still. So x is greater than or equal to 6. And if you need to, on the number line, put a 6 in the middle, start at the 6 and shade in the direction that the arrow here is pointing, which is to the right, which I think you'll see is like that. And so start at the 6, go to the right, and shade that way. But I'm not told to stop anywhere, so I have to keep going forever. And because this is greater than or equal to, that's very important, we have to use a square bracket. So we start at the 6 and go to the right. So there you go. That means that the domain for this particular function will be 6 to infinity. Include the 6, exclude infinity. Alrighty. Well, there you go. We now know one time during which the function will not be all real numbers. Alright, that's it for this video. I'll see you in the next one. Have fun.